So, topic 6, SAS 3. It's on page 153. All right, so yesterday in SAS 2, it talked about something called a complex number on page 18, okay? A complex number is written in the form of A plus BI, okay? Go ahead and write this down on number 1, like around number 1 on your paper as well. So a complex number is when it has an imaginary number, has the imaginary I. So this A and this B are real numbers. So they're actually going to be numbers there, okay? But that I is just going to be I because the I stands for imaginary. All right, so if you hit play, it's going to show you your imaginary numbers. Why do you think those up top in the purple are all imaginary? They all have a what?
I.
They all have the I, okay? If you hit the number 2, now you have complex numbers. What is the difference between the complex number and the imaginary number? The complex has the real component. So remember, complex is A plus BI. Imaginary is really just the BI. All right, so on your paper, you've got some boxes. Okay, in that first box, what kind of numbers are they?
Complex.
They're complex. So go ahead and fill in complex numbers for that first box. In the second box, those numbers just include the I, so those are just considered what? Imaginary. And then the last box are just plain old what? Look at your choices. What's the last one? They're real numbers. Okay? Real numbers right here. Whoops. Real numbers include whole numbers. They include integers. They include rational numbers. And they include irrational numbers. Okay? So, see where it says number 4 in your box? What is number 4? Is number 4 a whole number, integer, rational number, irrational number? It's a whole number, okay? What about -5? What is it? It's an integer because it's negative, yeah. The 0.7. It's 2 things. 3 things, really. It's a real number. It's an integer. And is it rational or is it irrational? So rational means it stops or it repeats. And irrational is just a crazy decimal.
Rational.
It's rational. Just stops. 0.7. What about the square root of 2? Type the square root of 2 in your calculator. And no, it's not 1. Is it a crazy decimal? So the square root of 2 is an irrational number. What about 2 over 3? Is it 0.6666667? So since that 6 is repeating, is that going to make it rational or irrational? Rational because it's repeating. Okay? So what this means is all numbers are complex. All numbers are complex. If I just write 5, okay? Just write the number 5. Remember, complex is A plus BI. What is that number missing? It's missing the what component? It's just missing the complex. So 5 is the same thing as me saying 5 plus 0i. Okay, so that's why all numbers are complex numbers, which is why your box on number 1 has complex at the top and it goes around the whole thing. Okay? Alright, let's look at number 2. Let's see. Does it give us the answer? Oh, no. Okay, so this is just like combining terms. Okay, so we combined like terms a few weeks ago. So right here on this first one, this one's not on your workbook, but it is on Agile Mind. So they added theirs. So we literally just, we're treating this like it was an X. 2 plus 3i plus 5 minus 7i. So I'm combining my real component. So 2 plus 5 is what? Okay, 7. And then we have 3 plus negative 7, which is a negative 4. Okay, so all I did was combine. Now the one it asked you to do on number 2 is subtracting. So we have, let me go to this. Oh, dang. Okay. So we have 2 plus 3i minus 5 minus 7i. So just like we did a few weeks ago, what do we have to do with this negative sign? We have to what? It will, this one will become positive. We have to what, Hayden? Starts with a D. Distribute. We have to distribute this negative to both. So right here, does the first set of parentheses change? Do we do anything to it? No. So we just have 2 plus 3i. This positive 5 becomes a negative 5. And then this negative 7 becomes a positive 7 because 2 negatives make a positive. Now we just combine our terms. So 2 minus 5 is negative 3. And then we have a 3i and a 7i to get a 10i. Okay? Questions so far? We're just combining like terms right now. Nothing fancy. All right, go to number 3. Okay. So you're gonna want to drag and drop your answers here because it'll give you credit for it. Okay. So this first one, we're just combining like terms. So 3i plus a 7i is what, Kendall? 10i. Good. Wait, did it move? All right, the next one. I'm going to write it out down here at the bottom. So we have a 2i plus 3 plus 8i. So When you write a complex number, the I always has to come last. Okay? You can never put the I first. It will count it wrong. Okay? I has to be last. It has to be A plus BI or A minus BI. Okay? So, the first number they already give us is a 3, so we can mark out our 3. So, Nicholas, what is 2I plus 8I? 10I. So, this answer is 3 plus 10I. So, you're going to drag that 10I right there. All right, the next one. We have 3 plus I minus 5 plus 3I. Sam, what do I have to do with that negative sign? Distribute it. So we have a 3 plus I, and that'll make that a minus 5 minus 3I. All right, BG, what happens when I combine 3 minus 5? I get a what? A negative 2. And Lawson, what happens when I combine this I and this negative 3I?
A negative 2I.
Yep. So my answer is negative 2 minus 2I. All right, so D, what's different about D? Is it looking for where you start or where you end? It's looking for where you start, okay? So we're going to have to do some subtraction, okay? So I'm going to treat this like it says x plus 4 plus 2I equals 7 plus I. Okay? What do I need to do with that 4 minus 2I to get x by itself? Just like solving an equation. Since it's positive, I'm going to do what with it? If I've got to move it. I'm going to subtract it, right? So we have a minus 4 plus 2I. What am I going to do with this negative sign right here? I'm going to distribute. So now we have a minus 4 and minus 2I. So 1I minus 2I is what kind of I? What's 1 minus 2? Negative 1. So we just have a negative I. What's 7 minus 4? 3. So this answer is 3 minus I. Or what you could do is you could think, so I have a 4 right here, but I got to get to 7. So how many more do I have to have? I got to have that 3. Okay? I got a 2I, but I only want to have 1I, so what else should I do? Should I add 1 or should I subtract 1? Subtract 1. Okay? Either way it works. All right. Whoops. The last one. 4 minus 3I plus something equals 7I. So do you have a real component at all in that answer? In this right here. Is there a real component anywhere? Is it just imaginary? Just imaginary. So you have to essentially get rid of that real. Right? All right, so if I have a positive 4, but I want to get rid of it completely, am I going to have to add 4 more, or am I going to have to subtract 4 more? If I got 4 and I want 0, I'm going to have to do what? Subtract, okay? So we know we're going to have a minus 4. I've got a negative 3. But I want a positive 7. Plus what, Nicholas?
10i.
Plus 10i. Okay. So you can play it that way by looking at your terms and seeing how many more you need or how many more you lack. Or you can subtract it like we did on the fourth one. So either way works, okay? All right, let's go to number 4. Okay. Can you take the square root of a negative number?
No.
Never, ever, 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 ever. Okay? But what you can do is you can take the square root of the positive number and put what on the outside? An I. Okay? So what is the square root of positive 4? 2. So since this is a negative 4, this answer is going to be 2, what? Just 2i. What would be the square root of negative 49? 7 what? 7i. What about the square root of 100? Not 50. What, Nicholas? 10i. What would be the square root of 64? 8 what? 8i. You cannot forget the i's. Okay, you have to remember your i's. Now, on B, what is the square root of positive 10?
No, negative.
So there is a square root of 10, but is it type it in your calculator and see what you get. There's a square root of 10. Is it a decimal?
Yeah.
All right, we don't like decimals. Okay, so what you do, since you cannot simplify the square root of 10 to be a whole number, we keep that square root, and guess what you put on the outside? An I. So you can put the I in the front, or you can put the I on the right. I always put it on the left. That way I know it's not under that square root. Either one is fine, though. You only do that if you cannot simplify the square root. Okay? All right, the last one on C. Can you take the square root of 9? Can you take the square root of 16? So we can simplify. What's the square root of 9? 3. And what's the square root of 16? So I have 3 over 4. I. Good job. Does that make sense? So all I did was take the square root of 9 and the square root of 16 because this square root is over the whole thing. Since it's negative, you just put the I out there like you do any other time. Okay? Let's see. No, did I hit submit? No. Okay. All right, this is number 5. So, it says, consider the product of the square root of 5 and the square root of 2. What's the word product mean? Multiply. Okay. So, on number 5, it says, rewrite each number in terms of I. Hold on. I don't know what this is doing. Oh, yeah. All right, let me go to this one. I can do it on here. All right, rewrite each term tonight. So first, I just want you to write the square root of -5 times the square root of -2 equals. All right, can you take the square root of 5 and get a whole number? Can you take the square root of 2 and get a whole number? No, it's not 1. You think it's 1, but it's not 1. Okay, so all we're doing is we can't take the square root. We're just saying I square root of 5 times I square root of 2. So all I did was replace the negative with the imaginary. Okay? Now, it says, apply the commutative and associative properties to group imaginary and real factors. So the commutative and associative property is one means the order does not matter, and the other one means you can group them. Okay? So, how many i's do I have in this equation right here? So I'm just going to say, I'm just going to group them. I times I. How many square roots do I have? So I'm going to group the square root of, whoops, not that. The square root of 5 and the square root of 2. Now it says to multiply and simplify. So what is it? I times an I. An I squared. So I have an I squared. Now, when you multiply square roots, you just multiply the number under the radical. So the square root of 5 times the square root of 2 is the square root of, it's 5 times 2. You just multiply the numbers. Square root of 10. If I keep going, I squared and the square root of 10. Now, in just a minute, you are going to learn I squared, I cubed, I4, I5, and all the way up. So, right now, you must know, write this down and circle it. I squared equals -1. Anytime you see I squared, you are plugging in a -1. Okay? So on, y'all can't see this. I always forget that. Let me erase this. So right here where we have I squared and the square root of 10, what number am I going to plug in for that I squared? Negative 1. So negative 1 times the square root of 10 just means negative square root of 10. Okay? Now, is this right here, the square root of negative 10, is that the same, or negative square root 10, is that the same thing as me saying the square root of negative 10? No, because the negatives are in two different places. Okay? So this works. But does this work? No, because that negative is under the radical. Okay? All right, number 6. Okay. Let's see. We have first the square root of negative 7 and the square root of negative 3. Can you take the square root of positive 7 and get a whole number? Nope. Can you take the square root of 3 and get a whole number? No. So what am I going to do to both of these? This one's going to be I square root 7. And what's the square root of negative 3 going to be? Good, Rain. I square root 3. What's I times I? I squared. Square root of 7 times the square root of 3 is the square root of 21. But what did I just tell you I squared meant? Negative 1. So now we have a negative 1 times the square root of 21, which makes this a negative square root of 21. Not the square root of negative 21, but negative square root of 21. Does that make sense? All right, so this would go here. All right, the next one. Square root of 3 times the square root of negative 7. Can you simplify the square root of 3 any? Nope. So I'm just going to bring it down. What is the square root of negative 7? Can you take the square root of positive 7? Nope. So we're going to leave our square root, but we're going to put what on the outside? Now, we just combine. What's the square root of 3 and the square root of 7? I'll just keep my eye. This right here. All right, the next one, we have a negative square root of 3, okay? And we have the square root of 7. What's the only thing I can do? Can I simplify either one of them? Nope. So I'm keeping that negative. And then, what am I doing to 3 and 7? Multiplying, and I'm getting the negative square root of 21. All right, the last one. The only thing different is that it has a negative in front of that square root of 7. What do you know about negatives? 2 of them make a... So all I did was make my square root positive. So I have a positive 21. All right. Next is number 7. So I want this to stop. All right, so on number 7, we are going to use the box just like you would if it said 3 minus 2x, but this time it's just using an I. So on top, 3 minus 2i. And on the side, what is it going to say? Five plus 4i. So now, I want you to fill in the box. And then stop. All right, Grant, what is 5 times 3? 15. Braden, what is 5 times negative 2i? Negative 10i, good. Kendall, what is 4i times 3? 12i. BG, what is 4i times negative 2i?
Negative 8i squared.
Good. Negative 8i squared. Okay, so now what do we do with everything on the inside? We combine them. Okay, so I want you to just write them all out. So we have 15 minus 10i plus 12i minus 8i squared. What did I say that I squared equals, though? Negative 1. So now we have 15 minus 10i plus 12i minus 8 times a negative 1, because all I did was plug in negative 1 for that I squared. Now we literally just combine like terms. So we have y'all can't see that. Get them up here to the top so you can see it. So we have 15, and then we have a negative 10i plus a 12i, which is just going to leave us with how many i's? 2 i's. And a negative 8 times a negative 1 makes a positive 8. Then we have to combine our constants. 15 plus 8 is 23 plus 2i. Is this in the right form? What has to come last every single time? The I. Okay? So that would be my answer. Number 8. Most important thing to learn today. Let's see what it looks like. Oh. I don't like this one. Okay. Anything to the 0 power is what? One. Anything. Type in a crazy number on your calculator and raise it to the 0 power. What do you get? 1. Okay? So, under the process box where it has I to the 0, I want you to write anything to 0 power equals 1. Anything. If I raised my dog to the 0 power, he would be 1. Literally. Okay? Now, anything to the power of 1 is itself. So if I raise 87,000 to the power of 1, I'm going to get 87,000. So if I raise I to the power of 1, I'm just going to get what? Not 1. I. Okay? So in the second box, I want you to write anything to 1 power equals itself. All right, the next one is probably the most important one. I squared equals -1. So I want you to circle that one. All right, now we start where the processes come in. I cubed, I to the 3rd power, is an I squared and an I. How many I's do I have total now? 3. That equals a -I. Because what is I squared? -1, and a -1 times an I is a -I. What is one way that I can make I to the 4th? I can have an I squared and an I squared, right? When you're multiplying exponents, you add them. So I'm multiplying my operation. So what's 2 plus 2? 4, so that's where I to the 4. But what does I squared equal? So a -1 times a -1 makes a +1. All right, if I do I to the 5th, I'm going to start with I to the 4th times another I. Does that give me I to the 5th? Well, what was I to the 4th? What did we just write that it equals? 1 times another I. So 1 times I is just I. I to the 6th, I'm going to use an I to the 4th and an I squared, because 4 plus 2 equals 6. I to the 4th equals 1, and I squared equals, what's I squared equal? -1. So then a positive 1 and a -1 makes a -1. On I to the 7, I'm going to use I to the 6 and an I, because that has a power of 1. 6 plus 1 equals 7. What did we just say that I to the 6th equals? A -1. And I to the 1 is just an I. So a -1 and an I makes a -I. Last one, we have an 8. So I am going to use an I to the 4th and an I to the 4th, because 4 plus 4 equals 8. Now you have to go back. What did I to the 4th equal? So 1 times 1 equals 1. Now look at the last column. Do you see a pattern? One, I, -1, -I. 1, I, -1, -I. That pattern repeats every 4 times. Every 4 times. So I want you to draw a bracket from 0 to I cubed. So we have the first 4 terms, and I want you to write in big letters out to the side. I have to know these. You must know this pattern. The pattern, it just keeps going and going and going. So now that you know this pattern, and I ask you, what is I to the 5,763rd power? Are you going to want to do that 5,763 times? No. I'm going to show you the trick. So, but you have to know this. So the first one is 1. And then it is I. Then it's a -1. And then it's a -I. So write that and circle it. All right. Let's see. Let's keep going. Number 9. This is where it asks you to calculate the power of I. So how many times does it take before my pattern starts over? Every what? Every 4. Okay? So you are going to take your power. What is the power of I to the 44? What's the power? 44. You are going to take that power and you are going to divide by 4 because that pattern starts over every 4 times. Okay? Now, can't do it in the calculator unless it comes out whole. So we have to go back to like 4th grade and learn how to do long division again on paper. Because I bet half of you forgot. Am I right or am I wrong? I hope I'm wrong. All right. First one's easy. 4 goes into 44 how many times? 11. All right. What's the remainder? Does it have one? It doesn't have one. So, here's how you do this. You look at your remainder. If I say I have a remainder of 0, I'm thinking back. What is I to the 0 power? So guess what my answer is? 1. Your answers are only going to be one of the 4 numbers, or one of the 4 patterns. Okay? Now, the second one. We have four divided by, or 542 divided by 4. How many times does 4 go into 5? 1. 1 times 4 is 5 minus 4 is, I bring down the 4 goes into 14 how many times? 3 times 4 is? Four goes into 20. Five. 5 times 4 is 20, and I have a remainder of 2. What does that mean, Hayden? It's I squared, and I squared equals -1. So this answer is -1. Does that make sense? All right. The next one's a little bit bigger. So we have 3,433. So how many times does 4 go into 3? Can it? No. So let's go to the next one. 4 goes into 34. How many times? 8. 8 times 4 is? 34 minus 32 is? 2. And we bring down our 3. Now 4 goes into 23. How many times? 5 times 4 is 20. Subtract. We have 3. We bring down our 3. 4 goes into 33. How many times? 8. 8 times 4 is? 32. And we have a remainder of 1. So that means I to the 1 power equals? Ah. So this answer is ah. Make sense? All right. All right, let's do these. Oh, let's see. let's I'm gonna save 10 and 12 for a quiz next week. 10 and 11. Okay? So 10 and 11 will be on a quiz next week. If you want to write that down so you know exactly what to do, I'm giving you the problems.
Just those two?
Well, it'll be a few more, but you're going to know for sure 10 and 11 will be on there. Okay? All you're doing is combining like terms. All right, so now I want you to go to your Agile Mind. Or get back on your Agile Mind. And we are going to go through the more practice. Let's see. Okay. Number 1. Consider a quadratic equation in the form of x squared plus c equals 0. What value of c will result in the equation having exactly one real root? Okay? So, I'm going to write them out. X squared plus 0. X squared minus 9. X squared minus 5. X squared plus 9. And x squared plus 5. Okay. So, on your calculators, or we can do it right here on Agile Mind, I forgot. First, we're going to do x squared plus 0. How many times does that cross? Okay, crosses once. Keep that in mind. If we do minus 9, how many times does that cross? Twice. Keep that in mind. If we do minus 5, how many times does that cross? Twice. If we do x squared plus 9, does that cross any? No, so those are what kind of solutions? Are they real or are they non-real? They're non-real and they are, after the C, complex, okay? If we do plus 5, does it cross any? Nope, so which one only crossed once? 0. Now, if you did not have a calculator and it asked you, this is how you know. X squared minus 9. This is for this one is for 5 and 9. So I'm just going to do one of them. You have to solve for x, right? So what am I going to do to this 9 right here on the left side to get x by itself? Can I take the square root of 9? Remember, when you take the square root, you have a positive and a negative component. Two positives make a what? There's positive. And two negatives also make a positive. So that's why that one has 2. Okay? This one, if I subtract 9, x squared equals negative 9. When I go to take the square root, can I do that? No, which is why it's non-real and complex. Okay? So my only choice it could be would be 0, where it crosses at 0. So make sure you hit submit so you get credit. All right, number 2. You have this in your workbook on page 149. Yeah, go to 149. When it has exactly 1 root, our discriminant has to equal what? It has to equal 0. When our discriminant is positive, meaning it's a greater than 0, it's a positive number, we have how many roots? 2. What kind? If they're 2 non-real complex, we cannot see them, they have an I, then our value is what then 0? Less than. All right, number 3. Suppose you throw a ball straight up in the air from an initial height of 1 meter with an initial velocity of 25 meters per second. The height of the ball h is the function of time t in seconds. How many seconds after the ball is thrown will be exactly 20 meters above ground? Okay. Where am I plugging 20 in for? H. So I am saying 20 equals negative 4.9 t squared plus 25t plus 1. Okay. First, what I want you to do is I want you to find the discriminant. No, I don't. Take that back. I don't want you to find the discriminant. I want you to go to your calculator, and I want you to go to your y equals, and I want you to type in the function rule. Okay? Negative 4.9 x squared. We can use x, we can use t, it doesn't matter. Plus 25x plus 1. And I want you to go to your table. All right. Look at your choices. Okay? Out of your choices, okay, we're looking for when it's closest to 20. Your y value closest to 20. So it looks like it might be between 0 and 1. So which of your answer choices is between 0 and 1? It's 5.142 between 0 and 1? No. So we don't think we need that. What about negative 0.04? Is that between 0 and 1? No, because it's negative, so we don't need that. What about 0.672? Is that between 0 and 1? Yeah, so that may be it. The last one says 2 answers. 0.929 and 4.173. So I want you to hit graph now. How many times does it cross? So if it crosses 2 times, how many solutions am I going to have? Going to have 2, so it has to be D. Continuing from the last question, when will the ball hit the ground? So, if it's hitting the ground, what height is it at? If you're on the ground, 0. So you go back to your table. Let's see. 0 says 1. All right, we have to look for when table's going to be too hard to see. When y is 0. So let me window. Nope. Oh no, I don't want my X to be messed up. All right, when I plug in 5.142 seconds, do I get 0? Right here, is this 0? No. All right, so let's try 4.9. $1.99? No. $32. This last one ain't near then.
You forgot to plug in the value
Right here?
for the negative 0.04.
I did. Is that the answer, Ray?
I'm pretty sure.
If you missed that answer, I don't know when it stopped recording, but It's this. Okay. All right, Stanley wants to create a garden in his yard. The garden will be a square of grass, and he wants to surround it by 1 foot square tiles. He has 400 square feet to work with in his yard. What should the dimensions of the square of the grass be? Stanley wants to create a garden in his yard. So the garden's the green part. The garden will be a square of grass. So it's not really a garden if it's a square of grass. And he wants to surround it with 1 foot square tiles. He has 400 square feet to work with in his yard. What should the dimensions be of the grass? How do you find the square feet of something? What's a square feet? That's the... If I want to know the square footage of this room, or the square footage of your house, you're finding the what of your house? The area. So, 18 times 18. Does that get 400? 22 times 22? 20 times 20? 10 times 10?
It's 18.
It's 18.
How?
It's 10 times 40.
It's how is it 18 by 18?
We are not good at this. Let's see what the hint says. Set up a quadratic equation to model the situation.
18 out of 18 don't even get you 400?
What is 18 and 18?
324.
I don't know about this question. I don't know about number 5. I'm going to have to do some research.
Oh, wait. I plugged it in. It's 400.
What?
I plugged it into that equation.
Oh, here's why. Here's why. So, each tile, okay, what's the area of each small tile?
More than one.
Okay, so if you have a tile for each side, it's going to have how many on each side of it? Like, look at this corner of the grass. It has a tile here touching it, and it has a tile here touching it, which gives me the 2. 18 plus 2 equals what? 20. So that's where that comes from. We have 5 minutes. Hold on. We got to finish these. Okay, this one's easy.
Is it right?
The number 79.5 belongs to which set?
Real. Integer.
All numbers are what? What I tell you at the very beginning. Is it a rational number? Oh, it's not integer. It's not negative. It's not negative.
See? Joanne?
Jawan. That's Jawan's fault. So complex, all numbers are complex. Real numbers, unless it's an imaginary, it's going to be real. Rational is where it stops. The number negative I squared root of 11 belongs to which set?
Complex.
What else?
It's not rational.
Imaginary.
What's it? Is it an integer?
I don't know, is it?
Is it negative? Click it and see.
No. Because it's not real.
Oh.
All right. The last one. Which of the following could result in the answer of 20? Let's go the easy route first. Well, this is really not the easy route. We're gonna have to work them out. Don't be guessing. That's why y'all mess up. Y'all be guessing. All right. Oh, let me show you a trick. Hold up. Calculator. This will save your life. All right, on your calculator, you are hitting mode. And you see where it says real down here at the bottom?
Yeah.
Click the right and highlight A plus BI and hit enter. And now A plus BI should be blinking.
Yeah.
Okay? Hit second, quit. Now, type in your choices. Should work. Is that 20? It's 20I. We only want 20. So now type in 2 plus 4. To do the I, it's second with a dot. That does not work. 2 plus 4 I and 2 minus 4I. It does work. It gives me 20. Sure does. Whoops. 2 plus 4I and 2 minus 4I. All right, then we have a negative 5I and a 4I. It gives me 20 because 2 I's make a I squared, and I squared equals negative, and a negative make a positive. And the last one, 7 plus 13 is
30.
7 plus 13 is not 30. 7 plus 13 is what? 20, and an I minus the I. Do you have any I's left? No. Y'all are something else.
Oh.